In this video here, I'm going to go over this problem right here, which I've gotten some questions about only because I think we're just not reading the either TI-84 calculator correctly or SALT. So I think it's easier if I show you versus typing it up. So we have a quantitative variable is measured once a year for a 10-year period. And the key here is to note that the year is X, the measurement is Y. In fact, anytime you're dealing with time is always going to be on the x-axis because we consider that the independent variable, and then the y variable will be the response or the dependent variable that we're really concerned with. So I'm going to go ahead and open this up using SALT. And here we go right here. Come over to regression. And the thing that we have to remember here is that, the explanatory variable, which is our independent variable, it's the x-axis. That's going to be year. The response variable is going to be y, and then we have this dot plot right here. If I clicked on regression line, this is the regression line. Now, what regression lines do is this line represents the average of the minimum distances of all of these data points from this line. That's what the regression line tells you, all right? And when I scroll down here a little bit, we come up with all this stuff right here, okay? So real fast, we have the model summary table, and this right here is our formula, all right? So to interpret this, all right, I think it's easier if I just write this down because that's kind of a lot. So right here is really what it's saying. Y hat, which is our, let me get rid of this, Y hat, which is our measurement, all right, is equal to negative 0.7006x. X is going to be the year, plus 62.7133. And within this problem, they wanted 3 decimal places. So y hat is going to equal negative 0.701 x plus 62.713. So that's what we type into WebAssign, all right? Some other important pieces of information here. R squared, all right, is right here. That's our R value. And if we wanted to find the Pearson linear correlation coefficient, which is little r, all right, what we have to do is take that number. So let's go back to here. So little r is going to equal the square root of r squared. So little r is going to equal the square root of 0.9278, which means r is equal to 0.963. And if we go back, oops, sorry, you can see I cheated here with my calculator. If we go back here, you will notice that we have a correlation right here of negative 0.9632, which is exactly what we just calculated back here when I used my Google calculator, all right? However, the thing to remember is although this is a positive number, when we look at the regression line, that has a negative slope. So this is a strong linear correlation, all right? But it's going in the negative direction, which means as time progresses, the measurement is going to go down, okay? Now, for some of us, we may want to use our calculator to do this. So I want to show you what that looks like real quick. So going back over here to our calculator, let me open it up. I think I still have all the data stored in here, so I should be all right. So here we go. There's the detached screen, and let's maximize that. Move this over here so it looks nice. All right, so remember, anytime you want to put data into your calculator, click on Stat. There's a video I did earlier that goes over this. So we click on Stat, Enter, and of course, it didn't save it, so I'm going to stop the recording right here. I'm going to pause it, type in the numbers, and I'll come back. Okay, I'm back. Data is now typed in. So let's go ahead and let me show you how to do this. So we're going to click data's in, click on Stat. We're going to go over to calculate, all right? And this is where we need to be very careful, okay? Many of us are going to look at option number 4 and say, oh, linear regression, ax plus b, and that's great. But this is the wrong one. What this function does is it just takes 2 points and it randomly picks 2 of them and it finds the equation of the line between 2 points similar to what you did in algebra class. That's not what we're doing here. We're not finding the line between 2 points. We're finding the regression line, which minimizes the error in all the data points. All right. So the option that we want is actually down here. All right. It's number 8, which says linear regression a plus bx. So we're going to go ahead and we're going to click on enter. The x values are list 1. The y values are list 2. We're going to go all the way down to calculate. And there we go right there. So as you can see here, we get the same exact values, okay? It even gives us, it says, hey, remember, this is y equals a plus bx. So this is this is y equals 62.713 minus 0.701, all right? So just make sure you're aware of this. Also, I don't know if you noticed this, but if we go back to stat, we can calculate the 2 variable statistics. So list x is list 1, y is list 2, and all this really does for us, all right, is it gives you like the average of the x values, the sum of the x's, the sum squareds of the x's, the sample deviation, population deviation, and it also does it for all of the y values as well, all right? That's good information, but let's be honest, all right? The best thing that you can use is salt, because salt just organizes it all for you real nice and fast. Okay, so I hope this helps, and I'll see you in the next one.